This slot is for chemistry, and the topic before me is the genesis of separating mixtures. Genesis of separating mixtures. If we can recall from our first lesson that the whole universe is made up of substances. The whole universe is made up of substances, the earth crust, the atmosphere, the seas, and even we, the human. We are made up of substances too. And we were able to see what gave birth to chemistry. That is, chemistry came into existence as a result of search for better life, search for better clothing, search for better food, search for better drugs. That was what gave birth to chemistry. And now we want to study these substances that God has made available for us to live a better life, wear a better clothing, take a better drug. How can we make use of these substances around us? Now, like I've said, we have these minerals all around us. We have these substances all around us, elements and compound. And I'm going to be using these words, elements, substances, minerals, interchangeably because they mean the same thing. For a novice, mineral is the element is what we call mineral. I'll get to know that later. Now, these minerals that occur naturally, they do not occur in pure form. They do not occur in pure form. Sodium does not occur in nature in pure form. Magnesium does not occur in nature in pure form. And that was what gave back to the separating mixture, techniques of separating mixtures. And so we are going to be studying different techniques used in getting these elements in pure form for us to use. You can see we use lithium. We use lithium in car batteries. Lithium cannot be gotten purely from the ground like that. It has to be purified. And so these separating mixtures are many. We have evaporation, we have distillation, we have sublimation, crystallization, extractions, and so many. Now, we also have what we call these substances have their specific properties. You can also call these properties characteristics. When this characteristic is seen in a substance, it gives that substance its identification. And so we also have physical properties and chemical properties. The physical properties are what we can see physically immediately, and we can infer or conclude that this is a particular substance, this is a particular element. The chemical substance is associated with changes that substances undergo to form new substances. Now, it is after the physical properties that scientists went into chemical properties. It is from the chemical properties we now begin to build or invent new substances. It is from the physical properties that we now get the clothes. It is from the physical properties we now get chemical properties which give birth to the clothes we wear, the drug we drink, we take, and the food we eat. And so we have now these substances occur in three forms in nature. They occur in solid state, liquid state, and gaseous state. Now, these three forms is being determined by their temperatures. The solid state is determined by its temperature. Those minerals that are formed, that can be found in solid state, they have their temperature. The ones that can be found in their liquid state, they have their temperature. And likewise, the gaseous state. And so, I will just briefly explain some few separating techniques. And these techniques have industrial implications. Let me give a typical example of petroleum. From petroleum, in petroleum product, through fractional distillations or precipitations, different type of product are gotten, compound are gotten, elements are gotten. It is from one single petroleum we get petroleum spirit, the one we use, PMS, the one we use for driving car, CNG, we have a cooking gas, we have a diesel, we have a jet fuel, we have bitumen, we have candle, we have Vaseline. This is gotten from fractional distillation. And we have some that we have a method called evaporation, crystallization, fractional precipitation. This is where the method we use to separate soluble solid from a solution. Soluble solid from a solution. That is evaporation, crystallization, fractional precipitation. And we also have distillation. This method separates solvent from its solution. Solvent from its solution. For example, if I dissolve sugar inside water now, or salt, if I boil that water to dryness, I will get back my salt. That's distillation. I want to distill water out. And again, we use this distillation to produce distilled water, which is the purest water. And we also have crystallization, is a process where a solid precipitates out of a solution. This is formation of crystal. We also have evaporation, which is a process where a liquid substance transforms into a gaseous state. Water is an example. You continue to boil and leave the pot open. The water will evaporate to dryness. And so these methods were established, were adopted, and they are used today industrially. If you look at the world around us, you discover that yes, when miners go into the earth crust and extract these minerals, they have to take it to the factory, the company that purify them, that make them pure, so that these substances can be used for a specific purpose. And so you can see the reason why, even in the lab, they will train you as a student to know the importance of these separating mixtures, purifying mixtures. But at laboratory level, like in the laboratory level, we have like chromatography that is used for solutes from a solution, to detect a solute from a solution. Separating funnel, that is separating immiscible liquid from each other. So, and we also have decantation, filtration, centrifuging, that is separating insoluble solid from a liquid. Decantation, filtration, centrifugal, all these three are techniques that separate insoluble solid from a liquid. And we also have this that is applicable in the lab, which is sieving, separating solid of different sizes, separating out substances of different sizes. So I get you this for you to know the method we get this element in pure form. Now, before I close my lesson, there's what we call these substances that are formed, that are gotten in natural form, in nature. They have characteristics or properties. I want to tell you how they can be identified easily. We use physical properties to identify these substances. Physical properties to identify these substances. Now, what are the physical properties? We have the boiling point of a substance, the boiling point of a substance, and we have the melting point of a substance. We have the boiling point is that point where the liquid begin to evaporate. So if you want to identify a substance, the first thing, check its boiling point, followed by melting point. Does this substance, what point does it melt from its solid state to liquid state? Another property is density. The compartment of this material in a given space, which determines its weight, its mass. That is the density. The hardness is how hard this substance is. How hard, how strong is this substance? And we have color. Which color? Is it green? Is it brown? Is it yellowish? And so on. And also odor. The odor, what our nose can detect. Then the taste of this substance. Then the malleability. The malleability of a substance is how malleable this substance is. How is this substance? Can this substance be compressed or deformed to another form? How easy for this substance to be compressed to form a sheet, that is without breaking. That is malleability. How easily is this substance? How easily this substance can be deformed to form another substance? These physical properties are the primary tools scientists use to discover, to identify a substance. Let me give this example again. You don't expect a miner that goes into the earth crust to, there in the earth crust, you expect him to carry out chemical test in the will I call it grave now, underneath the earth, that can collapse on him anytime. So seeing it, the first thing he looks at is these physical properties. And the second one, I told you that the physical is the physical properties that give birth to chemical properties. It is when the substance get to the earth surface that scientists now begin to carry out the chemical properties of that substances, which is the changes the elements of that go to form new substance. That is the chemical properties, and which we are going to be seeing as we go further in studying chemistry. It is these chemical properties that has given us a lot of betterment, a lot of benefit, which were not available in centuries ago. And so, from here, we are now going to be studying what it is called atom. Atom, the building block of every substance. The building block of every substance is called atom. It is this atom that determines the chemical properties of every substance. It is this atom that determines the chemical behavior of every element. It is this atom that determines the chemical properties of every molecule, of every compound. And so in our next study, we shall begin with atom. Atom, which, like I've said, determines the chemical properties of every substance. Thank you.